It's all okay. And were you able to practice some sums with the concepts we learned?
I did a few, but like they're like they're all just pretty simple, so I didn't
Uh-huh.
like do that many.
Right, right. No, so that's what we'll do. I mean, see, the idea is not to overwhelm ourselves with a lot of sums, but we should do enough sums to make sure that whatever we have learned, we are able to apply
Yeah.
that in solving the problems. Okay. So let's start with the first one called estimation. So, what do you mean by estimation? Normal, in terms of day-to-day life. When you say estimation, what do you mean by that? And we'll keep it very much practical oriented. So that's why I'm asking you all these stupid questions. Can you see my screen?
Yes, yes, I can.
Okay. So what do we mean by estimation? I mean, just give me a very practical answer to that. You don't have to be mathematical for answering that. When you get an approximate value of something, when you estimate something, yeah. Let's say uh, daddy says finish some household chores. Yeah. I mean, we all work, right? So let's say daddy says, okay, finish some household chores. And how would you estimate? You'll say will take 30 minutes or 2 hours or 6 hours, depending on how much is the volume of work. Correct?
Okay.
Yeah. So we do estimation for everything that we do in life. Now, let's say you have to go to school. Um, you will estimate like, okay, my school starts at 9 o'clock. I need to wake up by 8. I need 30 minutes to get ready, 15 minutes to do my breakfast, and then 15 minutes for traveling to school. Yeah.
Okay.
So this is kind of estimation where you kind of think through what all you need to do. You break it down into smaller pieces, and then you come up with your plan. Right? I mean, we are doing this 1 hour class every week. We can do it every day, maybe 2 hours every day. And then
Okay.
you say, if we do 2 hours every day, then I will not have time because I have school, then I have homework, I have my personal stuff. I need some time for myself. Need to plan my day well. I need to sleep also to take but to get my energy accumulated. Yeah. So basically, in summary, estimation is something that we do every day for everything that we do. Now you think about it, right? I mean, you have to join this class at 6 p.m. your time. You would have estimated that okay, I have to make sure that I'm home before 5:30 so that no, I have time to settle down and then start the class. Yeah. So that's the practical side of it. Now,
Okay.
it's very important to be accurate. It's a lot more important to be accurate, but then are we accurate all the time? Probably not. We try to get an the the approximate value for something. Let's say, did you okay? Let's look at example of joining the class at 6 p.m. Did you plan to say, okay, I'll be home by 5:33, and then I will take exact 12 minutes and 30 seconds to get ready for the class, 2 minutes for joining the link? No, right? We do some approximation, and that is exactly what is the essence of estimation. Now let's look at some numbers. Okay, this is one number, and this is another number, 1.02 and 1.8. Just by looking at these numbers, just 1 second. Myra, sorry. Okay, so just by looking at these two numbers, what comes to your mind?
Um, they're decimals.
That is one. Okay, these are not whole numbers or integers, these are decimals. Okay,
Yeah.
that's one observation. What else?
They're both like very like accurate numbers.
These are accurate numbers, okay? But what else? There's one more observation here. This number is very close to 1. This is much closer to 2, isn't it? 1.02. It's one whole number and then this much of a decimal. This is one whole number and then this much of decimal. This one is very close to 2. If I say I'll give you $1.9, that is almost like $2. Yeah.
Yeah.
So 1.8 is very close to 2, wherein this 1.02 is very close to 1. Yeah. It's like if you look at it as euro, 1.02. If somebody says, I'll give you 1.02 euro, this is 1 euro and then 02 cents. Yeah. Not 02 cents, 2 cents of a euro. Yeah.
Yeah.
If I say 1.8 or 1.9, this is almost equivalent to 2 euros. Yeah. 1 euro and very close to 1 euro. Yeah. So this is where we come across that the concept of estimation. Now let's look at this 100, 199. If you look at these numbers, this and you have to round it to nearby 100. This is closer to 100 and this is closer to 200. So if you have to do rounding or get the approximate value for this, you will say, yeah, this is almost like 200. This is very close to 100. This one is also close to 100. Yeah.
Yeah.
This one is also close to 100. When you start thinking is when you have 149, 151. Now, if you have to round it to 100, these two numbers, these are very
Yeah.
close. Yeah.
Mm-hmm.
And very difficult to figure out. So there's some methodology that is derived, saying, okay, fine. Let's see if I have 1 and I have 2 here.
Yeah.
What is in between? 1.5.
Mm-hmm.
So 1 to something which is less than 1.5, so maybe 1.49, is always rounded to this. And anything which is between 1.5 to 1.99, you round it to 2. I'm just giving you an example. So basically, if you have to do any rounding or estimation of a number, this is your approach. You look at what is the average of these two. Whatever is little less than the average, that is closer to the first number. Whatever is above the average, that is closer to the second number. Any confusion so far? And you can be honest. I mean, if I'm confusing you, you can tell me. I'll try getting you rid of the confusion. Okay. You can hear me okay, right, Riddhi?
Yes.
Yeah. Any okay. Let's look at this. I will probably double click on this. Let's look at this number line, let's say. Okay. And you have 0. Let me look at the other part of the number line, which is starting from, let's say, 100 and going till 200.
Mm-hmm.
Okay. And if somebody says round something to the 100, okay, let's say you have
Yeah.
here 110, 140, 150, 160, 190, 200, then so on and so forth. So, so what I'm trying to say is, when you do estimation or rounding of something, you try to get it to the nearest possible best estimated number. Okay. So let's say if you have to round 140 to 100, meaning what is the nearest 100 that it is closer to? One, see, 140, you can add 60 to make 200. That is one possible nearest 100. Or you can subtract 40 to make it 100. Yeah. Where you have to do more, subtract or add more? Where is a bigger number that you're dealing with? You're dealing with a bigger number here. If you have to get it to 200, you have to add 60 here. If you have to get it to 100, the next, the smaller 100 than this, you have to subtract only 40. So you lean on the smaller number always. So now let's look at another number. Let's say somebody says round 121 to the nearest 100. Now, when you're looking at this number, which is the 100 place? This one, right? What this is the
Yeah.
100. Yeah. Now it says round it to the nearest 100. So you're talking about the hundreds place as one. What is the next value for this one? Next 100 for this. If you have to go to the nearest 100, let's say the nearest 100 is bigger than this. You can go to 100 or 200. You will not go to 300. Yeah. Because you can reduce this by reduce this by one or increase this by one. That's what you have to do. Okay. So now 121, you are trying to find the nearest 100. If you have to make it 200, how much you have to add? 79. If you add 79 to this, that makes it 200. If you have to make it 100, what do you have to do? You have to subtract 21. So
Okay.
if you want to go here, if you want to say that, okay, 200 is the nearest 100 to for 121, you have to add 79 to it. If you have to go to 100 as the nearest 100 for this one, you have to subtract 21 from this. That's how 121 becomes 100, right?
Yeah.
So basically, this helps you make the judgment where you have to deal with a bigger number to round it. Here you have to add bigger number 79, which is much bigger than this 21. So my nearest 100 is this. Let's do few more. Okay, let's say I have 7,225. Okay, and I have 7,000. Okay, somebody says round this to the nearest 100. How many hundreds we have in this number? 7,225.
200s.
Actually, you have 72 hundreds. This many hundreds you have, right? This many hundreds.
Yeah.
Yeah. So if somebody, and you're right by saying that you have two hundreds. No, in the hundreds place, you have two. Yeah.
Mhm.
So if somebody says round it to the nearest 100, so you're looking at the hundreds place. Yeah.
Yeah.
Rounding will either increase it by one or decrease it by one. That's how you have to look at it. So if you have to round this 7,225 to the nearest 100, meaning you're talking about the hundreds places too, it can increase by one or decrease by one. Like we said, okay, 180 is close to 200. Yeah. So what we did, the hundreds place increased by one. Yeah. It might be getting confusing, but let's do a couple of them. I'm sure we'll be able to make it simpler. So
Okay.
so let's start afresh. Okay. Let's say let's try to keep one thing in mind. Okay. If I have 0 to 50, 0 to 49, I can round it to only 0. Okay. If I have 51 to 99, I can round it to 100. Will that be okay?
Yeah.
0 to 49 is closer to 0.
Yeah.
51 to 99, I can round it to 100.
Yeah.
Okay. Now, so if somebody gives you 3 euros versus 63 euros, then you say, okay, 3 euros is as good as you have given me nothing. If somebody gives you 63 euros, then you'll say, yeah, this is closer to 100. Yeah. You just have to add some more of your saving into it, and that becomes 100. Yeah. This part is clear.
Yeah.
So 0 to 49 is almost like 0. 51 to 99 I can round it to 100. Okay, this is just a estimation part of it. Now let's look at the numbers. 7225. This is what I was saying. Okay, you have to round it to nearest 100. Okay, so I this can become 7200 or this can become 7300. Yeah, I'm not giving much respect to what I have in units place or tens place. So if I have to round it, I'll say, okay, yeah, this is close to 7200 or this is close to 7300. That's what will be nearest rounding for me. Yeah, for hundreds. Is it so far okay? No.
Yes.
Yeah, okay. Now, whether it is 7200 or 7300, that you will decide by looking at the last two digits. What you can do to make it like 100 or a 0. See, I said 0 to 49 is almost as good as 0.
Okay.
21 to 99 is 100. Yeah. So you will not change these two. You will look at the next two digits. Now this 25 is nowhere close to being 100 by itself. Much smaller than 100. Yeah. So
Mm.
and this is falling in this range. So I can replace this 25 with zeros. So whatever I had, I will put two zeros. My 25 is as good as 0. So this is my next rounded number. Now let's look at 8682. If somebody says round it to nearest 100, so nearest 100, what is my hundreds place? 6. So my nearest 100 will be this, or my hundreds place will increase by 1. Yeah. Now we have to decide
Okay.
which one is my answer. So I will look at the next two digits. 82. 82 is, as we looked at, 0 to 49 is almost 0. 51 to 99 is equivalent to 100. So I have 8600 already. This 82, I can make it 82. 82 is falling in this range. So it is almost like 100. So whatever value I have plus 100. So 8600 plus 82 is translating into one more 100 for me. So this is closer to 87.
Okay.
Am I getting closer to making you understand?
I think so. Yeah. Yeah.
Okay. Now let's play with this. So if I have 8947, what is the nearest? What is the rounding to the 100? If I round it to 100, what will be the value that I will say? Okay. My options are 8900 or 100 more than this. So 8900 plus 100 will be 9000. Yeah. Are you with me?
Yes.
So
So it
if
would
I
be 8900 because it's less than 50.
wonderful, you you are faster than I thought you to be. Okay. So yeah. So because you looked at the last two digits and you saw that it's less than 50, right? It's 0 to 49 range. So that is equal to 0. So this is what is your rounding. Now, if you have 9682, what will be the nearest 100 for this one? You have to round it to 100.
Would it be 10,000?
No, don't rush.
Okay. Oh, sorry. 9,700.
Yes. So I knew you know this one, okay, but I was just giving you that extra time because that's see, this is not complicated. This is easy. Just you have to give yourself few seconds. Say okay, fine. How you will make your brain work is like, okay, this is number. So I have to round it to 100. So this is my focus area. So I can make it 9600 or it can become 9700. Let me see which one it is. Now I'm looking at the next two digits. 82. 82 is much bigger than half of 100. Yeah. So yeah, it's leaning towards this one. Yeah.
Okay.
Let's do a quick fire. 1007. If you have to round it to 100, what will that be?
That would be 1,000.
Yes, be confident. You know this already, okay? So yeah,
Okay.
because you looked at these two digits, right? My this is see the options that I had was it could have been 1,000 or it could have been 1,100. That's it. But then when I looked at these two digits, this is much lesser than half of 100. So it's going here. Now tell me, okay, now I'll not try explaining it. Let's look at few numbers before we go to decimals.
Okay.
1,000, 1,742. To round it to 100.
It's 1,700.
100%. Yep, you're right. Same approach. Yeah. You looked at these two. Okay. 1,981.
Uh, 2,000.
Yep. Yep. Same thing. You looked at this and you looked at these two. And yes. I'm not explaining that because I'm getting a sense that you are getting it. Okay. This
That
one.
would be 2,200.
Wonderful. Yep. Rounding to 100.
Um, 3,900.
Wonderful. Now comes the trick question.
Okay.
Round it to hundred to tens place.
10th. 4,260.
Wonderful. So tens place.
5,990.
Wonderful. So you got this one now. Okay. Now round it to thousands place.
Uh, 10,000.
Yep. Round it to thousand place.
Also 10,000.
Wonderful. So this was a trick question, right? So this one you're looking at thousands place. So you're looking at this, and then what you will do is you will look at the next three digits, and this is 829. So again, like we learned, 0 to 49 is 0, 51 to 99 is 100. So you can extrapolate that. And if you're looking at thousands place, you're looking at three digits. So same thing here, 0 to 499. When you're rounding it to 1000, it'll be 0. And 500 to 999 will be 1000. Yeah. So you're looking at this number. Yeah. So same
Yeah.
thing. Basically, you have to always look at half of it. Which one is the lower half versus the bigger half? Yeah. If it's falling on the bigger half side, you will round it to one larger number for the that place. Yeah. All right. Now let's play with decimals. But before we play with decimals, I will show you some tricks. Okay,
Okay.
to play with decimals. If you have, let's say, 1.64, if you have to convert this into a fraction, what will you do? How much that will?
Um,
It's very. I'm sure you know it. I'm not trying to question you here. I'm just telling you. I mean, if you know, if I have to convert this decimal to a fraction, what will be my easiest answer for that?
um,
Okay, let me do it quickly because this is a trick. Let's do
Okay.
1.64. If I have to convert this to a fraction, what will I do? I will say this will be 164. I will just forget about the decimal for a little bit. Okay.
Okay.
And then comes the fraction. Whatever I have above, I will write it as is. Then I will take care of the decimal thing. So if I have a decimal,
Can you
there's
divide by 100?
yes. I will say this decimal. Yes, you're right. Your answer is correct. But I'm telling you the method for this one.
Okay.
So I have one decimal here, right? Any decimal will have only one decimal, never have more than one decimal, correct? You will not have a number like 1.42.62, right? You'll never have a number like this. You'll have always have only one decimal, correct?
Yeah.
So here I have a decimal, one decimal like any other decimal number. So I will put a 1 for that and then count how many digits I have after the decimal. I have two digits, I'll put two zeros. That's it. So if somebody says convert 4.6492 into a fraction, your simple answer would be I will write all the numbers as is. 46492. I have written that. And then I will take care of the decimal thing. Okay, I have a decimal here. I'll put a 1 for the decimal. And then count how many digits I have. One, two, three, four. So four digits, four zeros. Yeah.
Yeah.
If I have 1.21, convert to fraction. Simple. I will just write that number. Now take care of the decimal. Decimal puts a 1. And then how many digits I have? Two digits. Two digits equal to two zeros. That's it. Yeah.
Yeah.
So, I mean, here you don't have to do any calculation. I mean, no, we end up thinking a lot, but it should be more like a muscle memory, I would say. So, you have to convert 1.715 into a decimal. Simple. You will just write all the numbers without thinking about it. And then take care of the decimal. Decimal puts up, there's one decimal, so you're writing 1. And how many digits I have? Three digits. Done. Yeah. Now somebody says 0.059. Convert that into a fraction. What will you do? Put all the numbers as is. Okay. And then what will be the denominator here?
1,000.
So yeah, so you'll put a 1 for the decimal and three zeros. Three digits, three zeros. You know that putting any zero ahead of this doesn't make any sense. It doesn't do any change. Yeah? So I can write 0059 as 59 also.
Okay.
Yeah. So zero is a very mischievous number. Okay. Zero is a very mischievous number. You have, let's say, 1. You put a 0 here, no problem. You put one more 0 here, nothing changes. You put one more 0 here, nothing changes. But
Yeah.
you make a mistake. Okay, saying 0, putting a 0 doesn't make a difference. You put a 0 here, everything changes upside down. Yeah. So, so that same thing applies in case of decimal also. If you have, let's say, 0.5, if you put as in case of decimal, right? I mean, sorry, I made something. I said something wrong. If I have a regular number, whole number, natural number, I put a 0 before, no problem. Another 0, no problem. Another 0, no problem. I put a 0 after this, number changes. Yeah, 1 became 10. One more 0 became 100. One more 0 became 1000. But in case of decimal, that is not the case. You can put as many zeros you want. After the decimal also, no problem. Before the decimal also, no problem. Okay. So point 0.5 is 0.5, 0.5 or 0.50, it's all the same number. Nothing changes. This part is clear, right? I'm just repeating myself. I know this is not nothing new, but this part is clear, right? Riddhi?
Yes.
Okay. Now, so that's why I was saying the 0 is something that is not a very easy number to deal with. 1 is 1, 1 remains 1 always. If you put 1 after 1, it becomes 11. If put 1 before 1, that also becomes 11. But in case of 0, that is not the case. You have a number before, you put a 0 before, no problem. Put a zero after, that changes. In case of
Mhm.
decimal, you can play with as many zeros you want. No issues. Nothing changes. Yeah. But only care you have to do is if you have 0.1.042, you're putting a zero before, after, or before, no issues. Only thing is, in case of decimal, don't think of injecting a zero in between because that changes the value. Okay. All right. So this is
Yes.
the calculation part. Now we are coming towards the estimation side of it with the decimals. Yeah. Now I have a number 1.3. How do you, I mean, if you just look at any number like this, what is your interpretation from that?
Um,
I know I ask questions which other math teachers don't, I'm trying to relate it, with how we look at a number. How do we think about it? Yeah. Yeah. So it's not a mathematical question. Just think and tell me. If you look at 1.3, what is it? What comes to your mind?
uh,
Okay. I made you overthink. If I look at 1.3, what it means? I have a whole number that is one,
yeah.
and then I have a decimal part to this number. Yeah. I can as well write this as 1 and point 0.3, isn't it?
Yeah.
Yeah. So basically, whenever you look at any decimal, you're saying that any decimal number, let's say somebody says 5.7, it has two parts. Whatever you have on the left hand side of the decimal, that is your the natural number or the whole number part or the integer, whatever it is, right? Depending on the sign. And then whatever you have on the right hand side, that is the decimal part. So any decimal number, you can say it is, I can break it into that the whole number and the decimal. Yeah.
Mhm.
So far, it's okay, right? Are you with me?
Yes.
Okay. And don't hesitate. Okay, even if, see, people say, "Oh, this one you don't know. This is so easy." No, I don't ever say that. It's okay not to know. If I don't know something, I don't know. I will acknowledge it
Okay.
and I will learn it. So so never feel shy. Okay, if there's something that you are hearing and that you're supposed to know, and you have to say that, okay, you don't know, that's okay. No,
Okay.
nothing is going to go wrong. If I look at I would not say 1.1. I will not pick this number. I'll say 1.23. So, like any other decimal number, if I have this, my simple reading of this will be, okay, this has one whole, and this is the decimal part of it. So if
Okay.
I want to break it down, I will write the one whole part of it, and I can write the decimal part aside.
Okay.
And why I'm doing all this right now is so that we can think about the number before we do comparison. Okay, now let's look at 1.2. What I said, it is 1 and point
Zero
0.2.
point two.
Yeah.
Yeah.
Now I see 0.2 looks something little funny to me. I am not really comfortable with a decimal. How do I read
Okay.
this? So let me convert that into a fraction. 0.2, I will convert this into a fraction. How much that will be?
2/10.
2 over 10. Yeah. And you don't like this 0 before, this is unnecessarily taking space, you deleted that. Yeah. So you converted
Mhm.
this decimal to a fraction. Now, if I look at this number, what does it mean to me? Two things divided into 10 people. Is that a way to read it?
Yeah.
It's like, if I have two apples, right? Let's say
Mhm.
uh, you got two apples, and then you and Siddhi were there at home, and then you invited eight more friends. That made it 10 kids. Yeah,
Yeah.
distributed among all of them. So two apples divided among 10 kids. That's what it is, right? That's how I'll read it practically. Yeah. Now, if you have to compare 1.2 and 1.3, how would I read it? Okay, it's 1 plus zero point 0.2 and 1 plus zero point 0.3. Yes.
Yeah.
Or 1 plus 2 by 10. Yeah, that's what the fraction would be. 1 plus 3 by 10. Yeah.
Yeah.
Now, between these two, we know which one is bigger, which one is smaller, right? One is common between these two, and then here, this is two apples divided among 10 kids. This is three apples divided among 10 kids. So every kid gets a bigger slice here in this case. So it's easy to find that out. Now, let's look at the rounding thing or estimation thing that we were talking about. Now, if I have 1.4 and 1.5, and people say round it to the nearest integer or or a whole number, what will that be? 1.4 and 1.5, round it to the nearest integer.
It would be 1 and 2.
It'll be 1 and 2. You are spot on. So you got that. I'm sure the thought process that you would have probably applied would have been like this and this. Now, this one is 1. Don't worry. Now, 40 cents versus 50 cents. 40 is in the range of 1 to, sorry, 0 to 49, equal to 0. 50 is in the range of 51 to 19, sorry, 50 to 99. Yeah, that makes it 1. So this portion becomes close to 1 euro. This portion becomes close to 0 euro. So that's how this is rounded to 1 plus 0 is 1 and 1 plus 1 is 2. Yeah.
Yeah.
So now if somebody says, let me not deal with 1 anymore, 221.64 and 320, 314, no, 364.21. Round it to the nearest integer. What will that be?
It'll be 364. Well, sorry, the second one is 364, the first one will be 322.
Okay. This will be the second one.
364.
Sorry, say that again.
364.
Okay. Now, this is one part of it. So you converted. So if you're asked to round it to nearest integer, that was easy, right?
Mhm.
Now, if somebody says round it to the tens place,
Okay.
how much this will be? Tens place.
10 is
The
be
first one.
320,
Okay.
and then 360.
Tens place. Yeah. Okay. Okay. If
Yeah.
somebody says round it to hundreds place, what will be the
Three-
first one? What will be the second one?
300 and 400.
Yeah. So see, you got the crux of it, right? So you have, let's say, 469.97. If you have to round it to integer, that will be,
470.
yeah. Be confident. Even if you make a mistake, if you make a mistake, we'll correct it. That's fine.
Okay.
Don't hesitate. Okay.
Okay.
Okay. 470. If you have to round it to tens place,
470 as well.
yeah, round it to 200s place.
500.
Yep. So you know it now, right? I mean, you don't really
Yes.
have to worry about this thing. And in the course, what we learned was what is rounding, what is how do we estimate things, how do we round it to different decimals, no different places, and what does it mean? So again, We are not learning estimation or rounding for the sake of doing maths. We are learning it because actually it helps us. Now, let's say somebody says that to Riddhi and Siddhi, no, you won some prize, okay, and both of you will be given this many euros, okay. If both of you will be given this many euros, if you do this
Okay.
calculation, it might take maybe a minute and a half for you. Yeah. Instead, what you want to do, is it very important for you to know that okay, it is going to be 939 for something? No, you are trying to get a sense how much money it is. Is it 100 euro? Is it 1000 euro? Is it 5000 euro? Right?
Yeah.
Let's say if you have to buy a bike, will this be enough? Maybe the bikes come for 150 euros. Yeah. I mean, I'm talking about a regular one. Yeah. I might be wrong by 10, 15, 20% here and there, but for 150 euros, you should be able to buy a bike for your daily, ride. Yeah. So if you're getting this much price, then you know that okay, this is sufficient. This is probably more than enough. I can probably buy 6 bikes with this money. So
Yeah.
that is the estimation we do. So this actually helps you get a in your mind whenever you're dealing with this kind of, just by looking at this number you say yeah, this is somewhere close to 700. Okay, is this enough for what I'm wanting to do? So
Yeah.
that is the main purpose of estimation. And how we do it, how do we do rounding, how do we get the approximate value, that is what we saw just now. Yeah. So what I would want is you spend some time, do some sums, and let me know if this is um, basically see what are the different types of sums that you have in your in your notebook, and anything that is not clear with whatever we have learned so far, you are connected to me on WhatsApp. You can send me those questions. Take a picture of those questions. Say, okay, this one I don't think I'm able to solve it with whatever we have learned, and we'll try doing it. Yeah, and that will also give me a, because right now whatever I'm kind of explaining you is based on the syllabus that Daddy had sent to me, right? So
Okay.
there could be more than that, and um, we may not be able to cover entire thing based on what I have. So when you see those sums and when you try solving it, and then you apply this method that I have talked about, yeah, read, analyze, and then Nike. I think we talked about this one, right? Did we talk about this method?
Uh,
No.
no.
Okay. So this is my strategy that I give to all my students. Okay. I say
Okay.
if you know this, you can solve and you can do your best with any of the sums. Okay. First is T stands for trust. You have to always trust yourself that yes, I can solve it. If anybody can solve it, that is me. If anybody can solve it, I can try it as well. So that is the trust that you have to build in your personality itself. That you have to start believing that okay, I know enough maths. I keep on learning. I'm always learning. I'll continue learning. So if anybody can solve it, I can solve it too. So that you have to keep it yourself. R stands
Okay.
for read. When you come across a question, read that question again and again. Read at least 2 times or 3 times. When you read the question, you will see that the question becomes easier. Okay. The biggest mistake that, okay, let me not talk about the mistake first. The approach. So trust yourself, and this has to be part of your personality. You simply go ahead and assume that if anybody can solve it, I can solve it too. Beat any sum. Okay. And keep that as part of your belief. And then when you come across a question, first thing is read. Read till you get tired and bored. Till you come to a point that yes, I think I have got all the information that is there in the question. Okay. So read the question enough. If you read the question 2 3 times, what I'm promising you is your question becomes easier, relatively simpler. Okay. Then comes the A. A stands for analysis, meaning once you have read the question enough, you have understood what is being asked. Then you put your brain to work. You start analyzing. Okay, this question is asking me to do XYZ. Okay, and this has given me this information. I can use this formula. I can apply this, and then I should be able to do it. So this is when you're making your brain work. Okay, that you're applying your knowledge and associating that with the question that you have, and you are creating a blueprint. Okay, this is how I'm going to solve it. Then comes the last step. N stands for Nike. Nike's logo is just do it, right? That's the motto. I mean, that's what you call, that's the punchline of Nike, right? Just do it. So what I was talking about is, if you look at any math revolves around this. If
Yeah.
you apply this correctly, you'll be able to solve most of the sum that is for your grade or for your, any exam that you come across. Trust yourself that yes, I can do it. Because if by looking at any sum, if you give up the no, this looks way too complicated, you'll not be able to solve it. That I can give you in writing. So come out of that fear that okay, why would you come to a conclusion that I cannot solve it just by reading a question? So you have to trust yourself, and this has to be a part of your personality always. Okay, fine, let's see what how complicated the question is. I don't really care about the complexity of the question. Let me read first. Read 2 3 times, read, and then you note down whatever you read from the question, and will apply that. When we do sums, you will see how it works. Okay, so read the question enough so that you know what exactly is being asked. Then you
Okay.
analyze and think, okay, how I'm going to solve it. If you're able to wrap your head around this whole question, and then you're able to come up with a plan that okay, this is how I'm going to solve it. I have these informations, and then this is the formula. I know this is what I'm going to apply, and I should be able to find it out. And we'll apply that when we study more, when we read, go through the chapters, we'll apply this. So read, analyze, and then do it. The mistake we commit most of the times as a student is we start doing it blindly. This is the last step. Don't start solving the sum without reading it enough, without analyzing it, without coming up with a plan, and then doing it. Okay.
Yeah.
So that would be our approach. That is what we'll apply, and I'll show you how it works. Okay. So when we do different sums, that is why I want you to, whatever we learn in the class, I want you to kind of do some sums, find out the exercise book. And if you find any difficult question, don't worry about it. Get excited. Oh, I found something that I don't know. Let me try doing it, applying this by reading it enough, by analyzing, and then doing it. And if still I'm not able to do it, I have my uncle, my teacher, whoever it is, whom I can ask. Okay. Yep.
Yeah.
So that's what we'll do. So that's why I was saying this is very important. We'll use this. We'll bring this to action. Okay. When we solve sums. Now, estimation rounding we did. Now, I'll give you a class example. Okay. Now, let's say somebody says this divided by 9.72. Get me the approximate value of this. Trust me, if you try dividing this by this, it's going to take a long time, right? It'll take time. If you have to get the approximate value, what will that be?
Um, 5. Oh, it's a 5/10, so about a half.
Yeah, about a half or zero point 0.5. Yeah.
Yeah.
Now, let me let's see whatever we will do in the subsequent classes also, that is going to be a function of all these basic operations that we deal with, right? So today we just did a recap of how do we convert a decimal into a fraction, right? I mean, probably the method that I showed you might make it little easier, like what I was saying. I will not put any brain, I will just put the number as is, then one decimal puts me one, and then how many digits? That many zeros. That's it. Now, if I tell you that I have a number like this, I have to convert this into decimal. Do you know how to convert that?
Will you just do 1 divided by 8?
1 by 8. Yeah, you tell me, I will keep on doing it. Okay, 1 by 8. So,
Okay.
how do you go about it?
Um,
Uh, okay, it's like a simple division, right? So,
yeah.
I will teach you something in a funny way, and then that you might be able to remember. And I'm sure you know it. I'm just teaching everybody my way, which I claim to be an easier way. Okay. I have to divide 8 by 1. Sorry, 1 by 8. 1 is smaller than 8. What to do? I'm stuck. Whenever I have a situation like this, whenever I want to borrow zeros, okay, if I put a zero here, then that math becomes easier, right?
Yeah.
My solution to this problem is a decimal. Decimal is a magical thing. Like I said, zero is a stupid thing, right? If you put a zero before one, nothing happens. If you put a zero after this, becomes 10. Same way, like zero I call stupid, I call decimal as a magical thing. You'll tell me why. If I put a decimal, if I'm doing a division, right? Decimal gives
Yeah.
me n number of zeros till I want, meaning one zero at every step. It is decimal is like a chicken which keeps laying egg, or a hen that keeps laying egg, one egg at a time. Okay. So I put the decimal, it laid one egg, made it 10. Yep. Now I can continue. This is my decimal, okay? Now 10 is bigger than 8. So can say 8 ones are 8. I will, what is my remainder? 2. Now this decimal, my hen is laying egg one at a time. Yeah. This is 20. 8 to just 16. What is remaining? 4. My hen is laying egg, one egg at a time. 8 5 is 40. Done. So now I have my answer is 0.125. I can as well put a 0 here. Yeah.
Okay.
So this chicken egg, the hen egg thing, right? You're not a vegetarian, right?
No.
Okay, good. Otherwise, people will start thinking, man, I've been asked to talk about something that I don't eat. Okay. All right. Now, so this chicken egg thing, now let's relate. This part is clear so far? So, see,
Yes.
what we are trying to do is we are trying to convert a fraction into a decimal. Same chicken egg thing. I have to divide 2 by 8. Now I know 2 is small, smaller than 8. No matter how many times I repeat the table of 8, 2 will never come.
Yeah.
2 is small. So I have to make 2 bigger so that I can do the division. See, you divide a bigger number with a smaller number, right? Here,
Yeah.
the number that we have to divide is smaller. So it has to be made bigger. Now comes my magical thing, decimal, or the hen that keeps laying egg. One egg at a time. It lays only one egg. Remember that, okay?
Okay.
At every step. I put a chicken here or a hen here. That laid one egg. Now it is bigger than 8. So 8 to
Yeah.
16. I can do my division. I got 4. My hen is still laying egg. One egg. 8 5 is 40. So my answer is 0.25. Yeah.
Mhm.
And 0.25 I can add a 0. No harm. Yeah. So it becomes 0.25.
Okay.
Was this chicken egg story known to you before? Or
I haven't heard it before.
Yeah, no, there's no story. Okay, I'm just cooking it up on the fly. Okay,
Okay.
so we kind of did a recap of how do we convert a decimal to a fraction. Yeah,
Yeah.
and we learned how if I have a fraction, how do I convert that to a decimal? Yeah,
Okay.
using the chicken egg thing.
Okay.
And this chicken egg thing is nothing. It's simple division. Basically, once you go into decimal, how it works, right? So we'll do one last sum before we go on to the next one. Now, let's say I have to divide 20. Let's say 28 by 8. Okay. So 8 3 are 24.
Mm-hmm.
What is remaining is 4. Now 4 is smaller than 8. Again, we are stuck. And that is when the decimal comes to our rescue.
Yeah.
Yep. Now this decimal is that hen that is laying egg. As soon as we put a decimal, it laid one egg immediately.
Okay.
8 5 is a 40. Done.
Yeah.
So don't look at this anything different from regular division. Just that we made it little interesting by bringing that chicken egg story into picture. That's it.
Mm-hmm.
Yeah. Now, why I was saying so is now let's say you have 3.95 divided by 16.28. Okay. And
Yeah.
get it to the nearest one decimal place. What will you do first? You'll first convert this into a regular approximate value. You have to get the
Yeah.
approximate. So this will be 4. Yeah.
Yeah.
And this will be the denominator will be
16.
16. So now it has come to a point where it will be 1 by 4, right? 4 by 16 is 1.
Yes. Or 0.25.
Yeah. And how this 0.25 came? Same thing.
Yeah.
One egg, 4 to the 8, 2. Again, one more egg, 4 5 are 20. Now, any fraction converting to decimal, any number being equal to this, that you'll be able to figure out by yourself. Yeah. In a more
Yes.
interesting way. I know I'm pretty sure you knew this, but I have just added some more spice to it. That's it.
Mm-hmm.
Yeah. All right. Now we are pretty much close to the. Okay. Hmm. Then comes rounding answers to a reasonable degree of accuracy and all. So what I would say is for the estimation topic, just do some sums and try to find out some complicated ones which you're not able
Okay.
to. Okay. So see,
Yeah.
usually we tend to solve the easy ones and say, yeah, we are good. I'm just changing the perspective here. I'm saying, okay, now you
Okay.
do some easy ones and try to find some sums that you're not able to solve.
Okay.
And then you apply TRAN, the method that we talked about, and see if that is helping. Meaning you read the, I mean, simple way, even if you don't remember the TRAN concept, simple approach has to be read the question couple of times. If you are reading
Okay.
it first and then you are finding it complicated, read it 2 3 times and then see if it is looking little easier. Read 2 3
Okay.
times, note it down, then analyze how you're going to solve it, and then try solving it. And then also it doesn't work, I'm here. Okay.
Mm-hmm.
So that would be our approach. So that brings us to the end of this chapter estimation. Let me stop recording first, and then we should be